Hello my dears, how are you all? So yesterday I couldn't take class because of some personal need. I didn't get time. So today we are going to discuss. So in the last class was what we studied, my dears. I think in the last class we studied about the polar plot line. Polar plot we studied. I think almost we completed the concept of polar plot. So I hope you all cleared the concept, and if any problem regarding the polar plot you can do right now. So today we are going to discuss another important topic in your syllabus, that is nothing but gain margin and phase margin. First one, gain margin or GM. Gain margin and phase margin we are going to discuss. So what is mean by gain margin, my dear? Write the definition first, then we can explain that. Okay. The gain that can be, or the additional gain, that is the additional gain that can be multiplied with the system gain, so that the system goes to the edge of instability called the gain margin. And the gain margin is always calculated at phase cross over frequency omega PC. This is the definition, my dears. This is a definition. So what the definition says, gain margin is nothing but every system have a certain gain, my dear. Certain gain, let it be open loop or closed loop gain, it having certain gain. Let be open. What we are going to do, we are going to analyze, or we are finding the stability of a closed loop system by simply looking the open loop system, or by getting some parameter from the open loop system. We are trying to find the stability of the closed loop system. That we are all doing this phase margin and gain margin concept. Okay. And one more thing, my dear. So the gain margin is nothing but, so every system having certain gain, my dear. Certain gain, every system having certain gain. Okay. So if suppose the system is unstable now, you imagine the system is unstable now. Okay. Suppose I am multiplying some more gain here, let be G2, some more gain here. I'm multiplying with the system. What happened at that time? The system suddenly go to the instability. So the system suddenly go to instability, or the additional gain that can be added, or added in the sense that can be multiplied with the original system, so that the system suddenly goes to the instability. Or instability, suddenly go to the instability, right? Instability is called the gain margin, or the additional gain that we multiplied with the system now, this gain is called the gain margin. This gain is called the gain margin. See, it is like yes, it's a very good example I can tell you. Suppose a ship, suppose it's a ship, my dears, it's a ship. It carries maximum weight up to 1000 kilogram. You imagine 1000 kilogram. Suppose 1 kilogram you added to the ship will sink to the water. That means its gain margin is similar to the ship and its weight bearing capacity. Suppose it's 1000 kg now, the ship is stable, the ship can easily go above the water. But if suddenly if we add 1 more kilo, my dear, 1 more kilo to the ship, what happened? The ship will go to instability, it will sink. it will sink. In same manner, the system can have certain gain so that the system work very smoothly in stable manner. But what happen if you multiply a gain? Multiply a gain means you can add or you can multiply. You can multiply a pole or zero will definitely change the gain of the system, my dear. Pole or zero means nothing in physical meaning. What it is actually? Suppose you add a resistor can do anything. Okay, suppose resistor can't do anything. Suppose you add inductor or suppose you add a capacitance to the system, its overall gain will change, my dear. Overall gain will change. So that addition will cause the system to instability. So the additional gain that can be added to the system so that the system go to instability is called the gain margin. In ship and this weight bearing capacity, what is the gain margin now? 1 kilogram is the gain margin. This is actually the stable gain. This is actually the stable gain. So we added 1 more kilo so that the system go to the edge of instability. That is called the gain margin. That is called the gain margin. I think the concept is very clear. I think the concept is very clear to you, right? Very clear to you. Okay, and always the gain margin is always calculated at a phase crossover frequency, my dear. The gain margin is always calculated at phase crossover frequency. I will tell you what it is. So the equation for gain margin is nothing but, my dear, gain margin is equal to 1 by mod GH at omega equal to omega PC. 1 by mod GH at omega equal to omega PC. Omega PC is nothing but phase crossover frequency. And what is that phase crossover frequency means? Phase crossover frequency is nothing but the frequency, or I can tell you the angle GH equal to minus 180. That means at what frequency the angle of GH is equal to minus 180 is called the what, my dear? Phase crossover frequency. At what frequency, whenever we are doing problems, this whole concept will be very, very clear to you. Okay, first time if you hear this, definitely you will feel, oh my God, what it is. It is nothing, I will tell you. Okay, so gain margin equation is 1 by mod GH at omega equal to omega PC. And what is omega PC now? Angle GH at angle GH which makes minus 180 degree. Or at what angle or what frequency the angle of the transfer function, open loop transfer function equal to minus 180 degree. That angle is called, my dear, omega PC. That angle is called omega PC. Is it clear? Is it clear? So gain margin and phase margin concept, phase crossover frequency, you get it? You get it, my dear? You get it? Okay, so this equation is very, very important. This equation is very, very important. Okay, so what is gain margin and what is phase crossover frequency? I think it's clear. Can I run this? Next one, phase margin or PM, generally PM. Again, write the definition, I will explain. The additional phase added to the system so that the system goes to the edge of instability called the phase margin, PM. And phase margin is always calculated at gain crossover frequency. Gain crossover frequency omega GC. I will tell you what it is. Similar to the gain margin, my dear, the system is actually stable. Before the system is actually stable, the system is actually stable. Suppose the system having an angle, suppose 130 degree. You imagine 130 degree, the system is operating and it is stable now. If you add some angle to the original angle, suppose you add x angle, my dear, x degree you add, suddenly the system goes to instability. Initially in 130 it is stable actually. Suppose you add some more angle to the system go to instability. Then that angle, my dear, the edge of that angle, the minimum angle that can be added to make the system unstable is called the phase margin. Is called the phase margin. Okay, similar to gain margin, there is no difference at all. Gain margin means already the system gain is stable enough. If you multiply some gain, it will make to unstable. And in the same manner, the system is already stable with some phase or some angle to the system. If you add some more angle to the system goes to unstable. That angle you added is called the phase margin. This is the simplest way I can explain. This is the simplest way I can explain the concept of phase margin. Okay, so what is the equation for phase margin? Let's do that. So there is an equation, my dear. Phase margin is equal to 180 plus angle of GH at omega equal to. So phase margin is always calculated at gain crossover frequency. Then what is this gain crossover frequency, my dear? What is the gain crossover frequency? Magnitude of GS equal to 1 at what frequency? What is when the magnitude equal to 1, what frequency the gain of the system, or simply the GH, magnitude of GS equal to 1, that frequency is called the gain crossover frequency. Mode GH equal to 1 at what frequency? Is it clear? Angle GH is equal to what? 180 at what frequency is the phase crossover frequency. Gain crossover frequency means mode GH equal to 1 at what frequency? That's all. And phase margin is nothing but 180 plus angle GH at omega equal to omega GC. These two equations, very very important, you have to remember. For problem solving it's very useful. For problem solving it's very very useful. Okay, is it clear, my dear? Is it clear? Phase margin and okay, is it clear? So what about the phase margin? So combinedly I can write the equation now. So this is the phase margin. So what was gain margin or gain margin? You can compare this equation. Okay, it will be very easy then. 1 by mode GH at omega equal to omega phi c. Correct na? Gain margin equal to phase crossover frequency. And what is phase crossover frequency? What is phase crossover frequency, my dear? The angle of GH equal to minus 180. If I said earlier it was is any different, this is the phase crossover frequency. If I think I did some other definition, right? This phase crossover frequency I did some other definition. If so, please change it, otherwise it's not. Okay, so omega pc is equal to angle of GH which is equal to minus 180, or that omega equal to omega pc. Or at what angle, at what frequency the angle of G is equal to minus 180, my dear. That's all. That is the phase crossover frequency. Okay, is it clear? Is it clear, my dear? Is it clear? So gain margin is equal to mod GH equal to gain crossover frequency is mod GH equal to 1 at what frequency? Phase crossover frequency is nothing but angle GH is equal to minus 180 at what frequency? And phase margin is equal to 180 plus angle GH is omega to omega GC, and gain margin is nothing but 1 by mod GH omega to omega PC. Here omega GC, here omega PC. So initially you may feel a small difficulty. Don't worry, when we are doing problems it will be very clear to you. It will be very clear to you. Okay? Okay my dears? Is that okay? Is everything is clear? Is everything is clear? Okay? And one more thing you have to add as a note. If omega GC or omega PC is invalid, then gain margin and phase margin is infinity. That note you have to know. Okay, that is a note actually. If omega GC, if somehow this is the equation for finding this one and this is the equation for finding this one, if the answer obtained omega PC or omega GC is not a valid answer, that we will discuss in the problem, it will be clear. If the answer is not valid for omega GC and omega PC, my dear, then the gain margin and phase margin, you can simply by closing your eyes, you can say it is infinity. It is infinity. It is infinity. Okay? Is it clear? And how can we analyze the stability? By using the gain margin, phase margin, the gain crossover frequency and phase crossover frequency, etc. I will tell you. This is very important. This is also very important. So make another heading. Stability of closed loop transfer function using open loop transfer function, okay, with the help of gain crossover frequency, phase crossover frequency, gain margin and phase margin. By using these parameters, my dears, these parameters, we can predict the stability of a closed loop system, but we are utilizing only the open loop transfer function. We get only we analyzing the open loop transfer function and we are finding the stability of a closed loop transfer function, my dear. That is the peculiarity of these phase margin, gain margin and gain crossover frequency, except phase crossover frequency, etc. Okay, so write one thing. If omega PC greater than omega GC, the system is stable. If omega PC equal to omega GC, the system is marginally stable. If omega PC less than omega GC, unstable. Make it inside a box, one box. If omega PC greater than omega GC, the system is stable, my dears. If omega PC equal to omega GC, the system is marginally stable. And if omega PC less than omega GC, we can say that directly it is the system is unstable. The system is unstable. And if, these all are if and other if gain margin greater than 1, gain margin equal to 1, gain margin equal to less than 1, system is stable, marginally stable, unstable. Same time, phase margin greater than 0, phase margin equal to 0, phase margin less than 0. Stable, marginally stable, unstable. You can remember like this. You can remember like this. It is actually a combined effect, my dear. If GM greater than 1, definitely the system will be stable. At the same time, its PM also greater than 0. If GM equal to 1, the system will be marginally stable. At the same time, PM will be 0. This is occur simultaneously, my dear. That is very important concept. It occurs simultaneously. Suppose if gain margin is less than 1 means the phase margin should be less than 0. The phase margin should be less than 0, my dear, and the system will be unstable. So the core fact is nothing but by simply looking the open loop system, we can find the stability of the closed loop system, and by observing certain parameter in the open loop system, that is nothing but the gain margin, phase margin, and gain crossover frequency and phase crossover frequency, and compare with something and compare it with, we can predict the stability of closed loop transfer function. Okay, by doing some problem it will be more and more clear to you. Can we do some problem, ideas? Can we do some problems? Okay, so gain margin is always associated with 1 and phase margin is also associated with 0 regarding the stability. That you just remember, my dears. Okay, can we do some problem so that the theory will be more and more clear? Okay. Theory will be more and more clear. Write a question, my dears. Write a question. GH is equal to 1 divided by S plus 9. 1 divided by S plus 9. Find phase margin. And our subscriber count na 500 now. Okay, our subscriber count reached 500 now. So really thank you, okay, who really shared our videos to your friends and others, and which makes the count of subscriber to 500. Okay, I know when compared to the other channel like entertainment channel, always the educational channel subscribers count will be very less. I know that. But I want to increase more. Did you see the movie KGF 2? In that, the subordinates of the hero, okay, who are mining the gold, and they asked the hero that, sir, is it enough? And the hero just count the number and saying, no, it is not enough. After 20-30 minutes again, the subordinates asked the hero that again, sir, is that enough? No, it's not again. The mining should continue. The mining should so hard. Okay. So those who are watching the movie definitely get what I am saying. Okay. Just I compare. Okay, that's simple, funny. Anyway, so what is phase margin here, my dear? So what is the equation for phase margin that you have to first of all, when we see this type of question, first we have to find the angle of GH. Before that, put S is equal to j omega. So it will be 1 by j omega plus 9. And what is magnitude of GH, my dear? Simply m. No, in polar part we represent with m now. So it is nothing but 1 by root of omega square plus 9. And what is angle GH? It is nothing but, my dear, minus tan inverse of omega by 9. That is the first thing you have to do. That's the first step you have to do with. Next we are going to find the phase margin. So phase margin is always, what is the equation for phase margin, my dear? Phase margin is equal to nothing but 180 plus angle of GH at omega equal to omega PC, right? Phase margin is gain crossover frequency, so omega GC. So for finding the phase margin, the first thing you have to find is always omega GC, my dear. Omega GC you have to find. Okay, so what is omega GC now? Omega GC is nothing but what I wrote for omega GC, gain crossover frequency. Gain crossover frequency is nothing but, my dear, at what gain the mode GH equal to 1. Sorry, at what frequency the mode GH equal to 1? That is called the gain crossover frequency. Am I right? At what frequency? At what frequency, my dear, I am again saying at what frequency the gain equal to 1 of the open loop transfer function, that frequency is called the gain crossover frequency. Now let's find that first. Okay, so what is mode GH, my dear? So I can, which implies 1 divided by root of, I can say like omega GC square plus 9. I replace omega with the omega GC because I am going to find the omega GC, which is nothing but equal to 1. If this condition is satisfied at what frequency? That is called the gain crossover frequency. That's all. So it is nothing but, my dear, omega GC square plus 9 equal to simply 1, correct? Or omega GC equal to minus 8, or omega GC equal to plus or minus j root 8. Am I right? Plus or minus j root 8. Omega square magnitude, oh my god, it will be 81. Okay, magnitude will be 81 now, my dear. X square plus y square na magnitude. So it will be also 81. So there's 81. So it will be simply minus 80. So it will be 80. It will be omega GC is equal to what? Omega GC equal to plus or minus j into root 80. Is this valid or invalid, my dear? Gain crossover frequency na, you have to substitute this j value in this angle form. At what angle which make the omega to omega GC na, the angle of GH you have to calculate. See the angle of GH equation. Tan inverse, what is that? Tan inverse j root 8 by 9. If you substitute this omega GC in this condition, that means simply but in angle, you will get this j root 80 numerator. Tan inverse j root 80, is it possible to find the angle? Array, tan or sine or cosine or anything, the trigonometric functions value simply varies from 0 to 1, my dear. Not from the j term, minus also there. Okay, definitely minus also there. This angle will be minus 1 to plus 1. Angle will be vary from minus 1 to plus 1. Okay, but there is no term containing j will be in angle, right? If you have root 3 into j, can you find the angle? No. I mean this tan function you can't put. You can find the angle, my dear, plus 3 plus j4. You can find the angle of this complex number. You can find the angle of this complex number. But if you have an equation like this and you have to put a value here, that value should be real. That value should not be j term. Or tan inverse j root 80 divided by 9. Is it possible to find? No. Is it possible to find, my dear? No. So I can say that omega GC, I will tell you now, omega GC is invalid. Is what, my dear? Invalid. Very, very important concept. Very, very important concept. If omega GC invalid, the system what is that? Phase margin is, what is that? Infinity. Already discussed, correct na? If any trouble in finding the gain crossover frequency or phase crossover frequency, definitely the system phase margin or gain margin, both you can say it will be infinity. Both it will be infinity, my dear. Okay, both will be infinity. So the phase margin is infinity is the answer. This type of question you can expect for your examination because it's just 2-3 lines, but the concept is not very, very deep. The concept you have to grab is very, very deep. Is it clear? Just note it, my dears. Just note it. Just note it. Just note it. Okay? Is it clear? Is it clear? Actually, I don't know why my video lectures got less view. I don't know exactly. I am delivering my maximum, but I think I am not simple. I am not in simple way. I am not explaining right, or I am dealing with more complicated problems I am dealing. So that is why the students, those who are watching, get less interested, because that system or the problem is very complicated now. They don't want to do that complicated problem. They always want V is equal to IR, P is equal to I square. That type of problem they expect, I think. I don't know. I think so. That type of problem they are expecting all the time. But my idea is tougher and tougher. If you get tougher and tougher, goes to tougher and tougher situation. Then you are in real world. If you face a very simple situation or easy situation, you will be very happy. So if you do very complicated problems in the classroom, actually my dears, this is not at all a complicated problems, okay. More complicated problems are there for IES examinations and GATE examination. The problem will be very tough. But compared to those examination, these problems are very, very easy actually. But I don't know why, okay. If you know the answer, you just comment it, okay. Or my language is a problem to you people. My bad English is a problem. My bad English is a problem. Array, my dears, don't focus on the language. Focus on the concept. Focus on the concept. That is the real. I mean, listen. GH is equal to, next question, GH is equal to 2 root 3 divided by S into S plus 1. Phase margin you have to find. Phase margin you have to find. Same question. Same manner, my dear. So what is the first step? Put H is equal to J omega, S is equal to J omega. So that 2 root 3 divided by J omega into J omega plus 1. Am I right, my dear? Am I right? So what is mod GH, my dears? Mod GH. It is nothing but what will be mod GH? Correct na? What will be mod GH? 2 root 3 divided by J omega root of omega square plus 1. And what is angle GH, my dears? Angle of GH. There is nothing. Not focus on this 2 root 3. Angle concept is not valid here. Then 2 root 3 you can't consider. It's a magnitude case. Na? So angle case will be J omega goes to numerator. It will form minus 90. Minus tan inverse omega by 1. Am I right? So that is the angle. So up to that you have to fight first part. Next you have to write the phase margin equation again. Phase margin equation. What is that phase margin equation? My dears? 180 plus angle of GH at omega equal to omega GC. That is the equation for phase margin. So you have to find the gain crossover frequency. So what is the gain crossover frequency, my dear? Omega GC is equal to omega GC is gain crossover frequency. At what frequency which make the gain of the system to 1. That is called the gain crossover frequency. Am I right? Phase crossover frequency at what angle? What frequency makes the angle of the system equal to minus 180. Okay, that's all. So omega GC you have to find, my dear. So what is again magnitude GH? So which implies I can write like 2 root 3 divided by omega root of omega square plus 1 equal to 1. Am I right? So taking the square on both sides, you will get this cross multiplication. Just to do cross multiplication and squaring both the term. 4 into 3 will be equal to omega square into omega square plus 1. Correct na? So I can write, my dears, I can write like 12 equal to omega raised to 4 plus omega square, or omega raised to 4 plus omega square minus 12 is equal to 0. Put omega square equal to x. So this is two equation become x square plus x minus 12 is equal to 0. Or what is x now? X is equal to minus b minus 1 plus or minus root of b square 1 minus 4ac 4 into 12 whole divided by 2. So it will become minus 1 plus or minus root 13. 12 into 4 10. 12 into 4 48 plus 9 49 whole divided by 2. It will become minus 1 plus or minus 7 by 2, which is nothing but, my dear, minus 8 by 2 or or 6 by 2, correct na? Minus 8 by 2 or 6 by 2. Okay, minus 4 or 3. So what you choose? For let us take like this, x is equal to minus 4 implies, my dear, omega square equal to minus 1. Am I right? Or omega equal to plus or minus j2. Correct na? Plus or minus j2. Am I right? Yes. And omega square equal to 3 or implies, omega square equal to 3 implies, omega square equal to 3 implies what, my dear? Omega equal to, what is that? Plus or minus, no root and all, simply root of 3. So you got 4 values for omega, my dears. One is that you got 4 angles. One is that j root 2 and plus or minus j2, and other one is plus or minus root 3. What angle you are going to prefer? For our consideration, the omega angle will be always positive, my dears. Always positive you need, right? Because for stability analysis, by using the gain crossover frequency, what we wrote, if omega gc, gain crossover frequency, greater than 1, equal to 1, less than 1 conditions are there, right? So for stability case, we just need the angle, omega gc, or I can say that omega gc you have to choose as, this is omega gc na? Omega gc you have to choose as simply root 3. Omega gc you have to choose as simply root 3. Okay, simply root 3, because always you should prefer the positive value. Then only the system will be stable. Okay. So omega equal to root 3 obtained. Then what is actually we want to find, my dear? Phase margin you have to find. Na? So can you rub this? Okay. So what is we have to find, my dear? Phase margin you have to find. So phase margin is nothing but 180 plus angle of GS, my dear. Angle of GS equal to what? Minus 90 plus this is the angle na? Minus 90 minus minus tan inverse omega. Instead of omega, what we have to do? Root 3 by 1. So it will be simply 180 minus 90 minus tan inverse root 3. What is tan inverse root 3, my dears? The root 3 by 2, 1 by 2, those place comes when the angle is 60, right? Angle is 60, right? So just take tan 60. Can you do what is tan 60? Sin 60 by cos 60, my dear. Okay, it is nothing but sin 60 nothing, root 3 by 2 divided by cos 60 1 by 2. 2 and 2 get cancelled, simply root 3. So our assumption is correct. So tan inverse root 3 is nothing but what? Tan inverse root 3 is nothing but 180 minus 90, you can directly like 90 minus 60. So it is nothing but 30 degrees. So the final answer is nothing but, my dears, phase margin is equal to 30 degrees. Final answer is nothing but phase margin is equal to 30 degree. Phase margin is equal to 30 degree. Is it clear, my dears? Is it clear, my dears? Is it clear? Can we go to next problem? If there is any doubt, you can comment. Okay. Definitely, if you look the problem for first time or second time or third time, my dears, definitely you will feel difficult and you don't know anything. You will be simply blank after seeing this problem. That is due to the unfamiliarity. Okay, don't worry. And you can absolutely say that the system is stable or not. You got phase margin equal to what? Phase margin equal to what? What do you got? Phase margin equal to 30 degree, right? Phase margin equal to 30 degree means the system is stable or unstable, my dear. If phase margin equal to 30 degree, the system is stable or unstable. You know that the phase margin and the gain margin values now. The phase margin and gain value margin now. If it is phase margin is greater than 0 means the system is stable. So it is 30 degree, of course the system is stable now. So the conclusion you can write, since the phase margin is greater than 0, the system is stable, that's all. And the gain margin also, if you obtain from after some doing this, you obtain gain margin is greater than 0, then also the system is what? Stable. So can you tell me one thing, my dear? If phase margin equal to 30 degree, definitely gain margin also will be greater than 1, na? Correct. You have to think, right? You have to think. Right? Another beautiful problem. GHS equal to 1 divided by S into S square plus S plus 1, my dear. And you have to find the gain margin, that's all. Not the phase margin now, my dear, it's now gain margin. So first step is nothing but you have to substitute array, polar plot and this gain margin, phase margin concept, everything. First step is just to put S is equal to J omega. So 1 by J omega into J omega square plus J omega plus 1. So it is nothing but, my dear. Okay, that's all. Simply that's it. It is nothing but 1 divided by J omega into J omega plus 1 minus omega square, because J square equal to minus 1. Correct, na? So J omega, I can double bracket I can use J omega plus 1 minus omega square. Okay, that's all. So what is mod GH, my dear? Mod GH is what? Mod GH is what? 1 divided by omega root of omega square plus 1 minus omega square, the whole square. Am I right? Real imaginary square plus real square. Correct, na? So it is 1 by omega root of omega square plus 1 minus omega square, the whole square. What is angle of GH, my dears? This J omega in the denominator go to minus 90 in numerator and minus tan inverse of omega, tan inverse B by A, omega divided by 1 minus omega square. Tan inverse 1 minus omega square. Am I right? That is the angle term. Next, what is we have to find? Gain margin. Write the equation first. Gain margin equal to what is? What is the equation for gain margin, my dear? It is nothing but 1 by mod GH at omega equal to omega PC. Phase crossover frequency, the gain margin will happen. Okay, the gain margin will happen. First time, definitely you will feel difficulty, my dear. Don't leave it. Don't give up. Try. 2-3 times you have to solve this problem on your paper. 2-3 times you have to do it. You will get an order, you will clear, you will get a clarity. You will get a clarity. Okay. You will get a clarity. Listen. So what is, my dear? We have to find, for this you have to find first omega PC now. So our task is to find omega PC. So what is the omega PC equation? Phase crossover frequency. What is that, my dear? Phase crossover frequency is nothing but the angle of GH which make 180 degree, right? The frequency at which the angle of GH equal to minus 180 is called the phase margin. Sorry, phase crossover frequency is called the phase crossover frequency, which implies, my dear, what is the angle GH? What is the angle GH? Minus 90 minus tan inverse omega divided by 1 minus omega square. So I can say that instead of omega, I can substitute directly omega PC, because we are dealing with omega PC na. So 1 minus omega PC square. So omega PC divided by 1 minus omega PC square minus 180. So at what is the value of now the omega PC? That is our phase crossover frequency. That's all. So it is nothing but, my dear. So I can take 180 here and a tan inverse there. It will form 90 equal to tan inverse omega PC 1 minus omega PC square. or I can simply say that, my dear, tan 90 is equal to omega PC divided by 1 minus omega PC square. Sin 90 by cos 90 is the tan 90. Sin 90 is 1, cos 90 is 0. Is equal to omega PC divided by 1 minus omega PC square. You don't just give up this and we need this. Omega PC square minus 1 is equal to 0. Okay? You can go that in way also, no issue. Omega PC is equal to omega PC is equal to 1 or omega PC is equal to plus or minus 1. Plus or minus 1. So what value you should take now for omega PC? Plus 1. This value you should take now, because we already learned for stability, analysis or stability, we are imagining the system is stable now. We are imagining the system is stable now. Okay. And you are doing all the analysis, and finally what obtained from that, you change your conclusion or you continue with your conclusion. That's the main fact. So omega PC is equal to what, my dear? Omega PC is equal to 1 you have to take, because omega PC less than 1 definitely make the system unstable. Then we don't need to do all this. All things will be in vain. So take omega PC is equal to positive plus 1. So once you got the omega PC equal to 1, that is nothing but phase crossover frequency, my dear. Phase crossover frequency, what you have to do? You have to substitute. You have to substitute in gain margin equation. So what is the equation for gain margin now? Gain margin is equal to 1 divided by mod GH omega PC. Am I right? So what is mod GH H omega equal to omega PC? First you have to find that, my dear. First you have to find that. So mod GH is already known, 1 divided by omega equal to omega PC, nothing but 1. So 1 divided by omega root of omega square plus 1 minus omega square at omega equal to, correct na? That is called the GH. So it is equal to 1 divided by 1 root of 1 plus 1 minus 1, 0. Simply 1. Simply 1, my dear. So what will be gain margin now? Gain margin will be equal to 1 by 1. This is equal to 1. If gain margin equal to 1, what is that conclusion, my dear? If gain margin equal to 1, we can say that the system is marginally stable. Am I right? So that is the answer. If gain margin equal to 1, if gain margin greater than 1 only, we can say that the system is stable. If gain margin equal to 1, I already gave the points, right? Gain margin equal to 1, less than 1, greater than 1, etc. So the system is marginally stable. The system is what, my dear? Marginally stable. So if the system is marginally stable, can you predict the phase margin now? What will be phase margin now? So phase margin will be equal to what? 0. That also you have to compare. The table, 2-in-1 table I already discussed, 2-in-1 table. That value you have to always remember in your mind. Always remember in your mind. Always remember in your mind. Is it clear? Is it clear, my dears? Can we go to next problem? Can we go to next problem? What is the time now? Oh, one more problem we can do. And what? And gain, if you want gain margin in dB, my dear. So already. You just give 20 log in dB. Suppose gain margin, if you want in dB, you just take 20 log of that. That's all. You will get the gain margin in dB. Now it will be here. What do you get now? Sorry. What do you get now? Gain margin equal to what answer you got? 0 na? Sorry, 1 na? Gain margin equal to 1 na? So log 1. So 0 dB will be the answer. Suppose you want in dB also, you can find this. Suppose you want gain margin in dB, then you simply substitute 20 log of that gain margin in magnitude wise. So you will get the answer. You will get the answer, my dear. Is it clear? Is everything is clear to you? Can we do another question? Can we do another question? Okay. Write another question. GH is equal to 1 divided by S plus 2 into S plus 3. You have to find the gain margin. Again, you have to find the gain margin. What is our first step, my dear? What is our first step? What is our first step? This is equal to 1 divided by G omega plus 2 into plus 3. Or magnitude of GH equal to what? 1 divided by root of omega square plus 4 root of omega square plus 9. Root of omega square plus 9. Okay? Okay? And what is angle of GH, my dear? Minus tan inverse omega by 2 minus tan inverse omega by 3. Right? That is the angle, right? Okay. What is we want to find? Gain margin. This is common to everything. Gain margin, phase margin, polar plot, everything it is common. So gain margin is nothing but, what is the equation for gain margin, my dear? Correct, na? 1 by mod GH at omega equal to omega PC. So we have to find the omega PC. Phase crossover frequency. So what is that phase crossover frequency, my dear? Omega PC is equal to what, my dears? Omega PC equal to what? Phase crossover frequency. Or at what frequency the angle equal to minus 180. At what frequency the angle equal to minus 180 is called the phase crossover frequency. Correct, na? At what frequency the angle of GH equal to minus 180. That's all. That is the phase crossover frequency. So what is the angle, my dear? What is the angle now? So this is the angle, right? Which implies minus tan inverse omega by 2 minus tan inverse omega by 3 equal to minus 180. Or I can say that every minus will be cancelled out. So tan inverse omega by 2 plus tan inverse omega by 3 equal to 180. So what is tan inverse A plus tan inverse B, my dear? Tan inverse A plus tan inverse B is nothing but tan inverse A plus B divided by tan inverse A plus B divided by 1 minus AB. It's a very big bracket. Tan inverse A plus B divided by 1 minus AB, my dear. Tan inverse A plus B divided by 1 minus AB. That is, this is everything. It's a whole bracket. Not, it's tan inverse for everything, numerator as well as denominator. Tan inverse AB, I will write now. Tan inverse A plus tan inverse B equal to tan inverse A plus B 1 minus AB. Tan inverse A plus B divided by 1 minus AB. Okay, tan inverse A plus tan inverse B. That equation you have to note. So which is nothing but which is equal to what, my dear? 180 degree. Or I can say that, which implies omega by 2 plus omega by 3 whole divided by 1 minus omega square by 6 equal to tan 180. Or I can say that 5 omega by 6 divided by 1 minus omega square by 6 equal to tan 180 is nothing but sin 180 by cos 180. Sin 180 is 0, cos 180 is minus 1. Correct, na? Cos 180 is plus 1. Sin 180 is 0, Cos 180 is actually what? Cos 180 is what, my dear? Cos 180 is minus 1, right? Yeah. 2 into 90, na? 2 into 90, right? 2 into 90, right? I think cos 180 is sin 180 by cos 180. Let's check that. Cos 180, cos of 2 into 90, right? 2 into 90. Cos 90 is cos 180. Cos 180, I think minus 1, my dear. 2 into 90, right? 2 into 90. Yes, it will be sin 90. It will be minus 1. Yes, cos 90 is minus. Cos 180 is minus 1. Anyway, numerator is 0 now. Focus on the numerator. Numerator is sin 180 by cos 180, right? Cos 180. Yeah, correct. Okay, so what will be? See, you can write like 5 omega divided by 6 whole divided by 6 minus omega square whole divided by what? 6. 6 and 6 get cancelled. Or I can say that, or which implies 5 omega divided by 6 minus omega square equal to simply what, my dear? 0 by 1. 0 by 1. 5 omega divided by 6 minus omega square, correct na? Equal to 1, or simply 5 omega equal to 0 or omega equal to 0, which implies what is that? Our omega PC, right? Our omega PC is equal to 0. Okay. Cos 180 is plus 1. Yes. So omega PC is equal to what? We got 0. Then you can substitute. You can substitute here. What is the gain margin now? What is the gain margin now? You can substitute here. The gain margin is equal to what, my dear? 1 divided by mod GH na. So before that you have to substitute. What is the mod GH at omega equal to what? 0. Which is nothing but mod GH as omega equal to 0 will be 1 divided by root 4 into root 9. It's 1 by 2 into 3, simply 1 by 6. So gain margin will be, my dear, 1 by 6. Simply but 6. 1 by 1 by 6, simply by 6. In dB, 20 log 1 by, so it will be 20 log 6. 20 log 6 in dB. Okay, is it clear, my dears? Is it clear? So log 20 log 6 will be the answer, right? 20 log 6 will be the answer. So can you find the stability now? Since the gain margin is greater than 1, gain margin not in dB, simply in magnitude greater than 1, the system is stable. I can say that the system is stable. Okay. Is it clear, my dears? Is it clear? Is it clear? So that's all about the today's session. One more problem can we do now? One more problem can we do? Actually, I am confused na. Cos 180 is sin 180 by cos 180 na. Tan 180. Tan 180 actually 0, that I know, 0, but sin 180 by cos 180. The simple thing, no, I forgot cos 180. I think it's plus 1, right? No? Okay, I have a confusion, I will clear it. Okay, next class I will clear it. That confusion doesn't alter my answer, because I got answer exactly, because numerator only tan 180 is absolutely 0, but sin 180 by cos 180 I just confused my dear. It's a simple thing, I know, but I confused it. I will clarify it and I will tell you later. Okay. Write another question. Write another question. GH will be 1 divided by s into s plus 2 whole divided by s plus 3. Again we have to find the gain margin. Okay. How can we do, my dear? Again the same step. S equal to j omega. What is mod GH? What is angle GH? Minus 90, na? This holds to minus 90. Am I right? Okay, what do we have to find? Gain margin you have to find. Gain margin equation you have to write 1 divided by mod GH as omega equal to omega PC, na? Phase crossover frequency. So what is omega PC? You have to find. Omega PC is equal to nothing but, what is phase crossover frequency, my dear? Phase crossover frequency is nothing but the frequency at which the angle of minus 180 degree. This, what is the frequency for satisfying this relationship? So again, what is angle GH, my dear? Which implies minus 90 minus tan inverse omega by 2 minus tan inverse omega by 3 equal to minus 180. So 180 come here, tan inverse go there. So it will have 90 degree equal to plus 90 equal to tan inverse. Alright, this problem you did now, na? This problem you did now, na? No. Yes. I got a similarity, that's why. I got a similarity, my dear. Tan inverse. Tan again, see, 90 come here, 80, so plus 90 will be here, and tan inverse A plus tan inverse B. But I told you, tan inverse A plus tan inverse B, tan inverse A plus B. All divided by 1 minus AB. Correct now? So again come here, tan 90 will be equal to omega by 2 plus omega by 3 all divided by 1 minus. So it will become sin 90 by cos 90, my dear. Sin 90 is 1, cos 90 is 0, na? Cos 90 is 0, na? It is equal to 5 omega by 6. 5 omega by 6 all divided by 1 minus omega square by 6. So it become 1 by 0 equal to 5 omega by 6 divided by 6 minus omega square by 6. 6 and 6 can cancel. Simply I can say like 6 minus omega square equal to 0, right now 6 minus omega square equal to 0, or omega square equal to 6, or omega equal to plus or minus root 6, or you can take plus root 6. So omega PC you can write like omega PC is equal to simply root 6. Other angle is also there, 5 omega equal to 1, but that make the system not stable but marginally stable. If another relation which clearly makes the system stable means you can take that relation. That's why I took the denominator. Okay. So now you got omega PC equal to what, my dear? Root 6, right? Root 6. So you can substitute now in the gain margin equation. What is the gain margin equation? This one. This one gain margin equation. So before that you have to substitute what omega equal to omega PC, or that is nothing but root 6. Omega equal to root 6, what will be the GH? You have to find that. It's 1 by root 6 root of 6 plus 4 root of 6 plus 9. So it become 1 by root 10 root 50. So only 1 by am I right, my dear? 1 by root of 900. 1 by root of 900 is nothing but 1 by 30. So GH at omega equal to root 6 is 1 by 30. Then what will be the gain margin? What will be the gain margin? What will be the gain margin? 1 by this one. So 1 by 30. Simply 30. So we can say that by simply looking the gain margin, we can say that the system is stable, unstable, or marginally stable. Now the gain margin greater than 1, since the gain margin less than the system is stable. That's the final answer. That's the final answer. Okay, so that's all about the today's session, my dear. So let's meet again tomorrow with the new problems. So until then, bye, take care. Okay.